So in this is a question on application of differentiation. No, this is a question on application of differential equation. So a colony of bacteria is allowed to grow in an experimental environmental condition. So the colony grows at a constant rate R and dies at a rate proportional to the square of the number of bacteria n at any time of the t days after the start of the experiment. So it is given that the population stabilizes at n0/2, where n0 is the initial population of the bacterial colony at t equals to 0. So we are asked to show that the growth of the bacterial colony can be represented by the following differential equation. Rate of change of the population of colony equals to this, so where k is a positive constant. So first thing we note that the rate of change of the population depends on the rate of growth minus the rate of death. So whatever that will be the rate of change of the population. So rate of growth is a constant rate r, so we just put r and dies at a rate proportional to the square of the number of bacteria n. So let b be the proportionality constant, which is greater than 0, because then minus, so then this proportional to the square of the number of bacteria n, therefore n square. Then this says that it stabilizes at n0/2. So therefore, when n equals to n0/2, when the population is n0/2, the rate of change of the population is 0. Stabilizer simply means that the rate of change of the population is now 0. So dn dt equals to 0 when n equals to n0/2. Then since dn dt equals to 0, so I change dn dt equals to 0 and r minus b n when n0/2. So n0/2 square. Therefore, I find that my r is just equals to b n0/2 whole thing square. Then we'll just substitute this r back into the differential equation, and we'll have this dn dt equals to, instead of r, replace with b n0 square over 4, right? Because n0/2 whole thing square is just n0 square over 4. Then after that, minus the bn square. Then from here, I just need to, because the question want it in the form minus k 4n square minus n0 square. So therefore, this one I will just factorize out the b, the proportionality constant b, and then divide by, factorize out 4 and negative as well, and then we will get whatever is inside of the bracket. It will be like the same as 4n square minus n0 square. So then b minus b over 4, since b is a constant, minus b over 4 is still a constant, so I just let k be b over 4. So b over 4, b is a positive constant, so b over 4 must be a positive constant. This means that k is a positive constant as required. Then the negative in front will be there, so there we have exactly in the form that they want us to have to show it. Then the next thing is what we do. When t equals to 0, the bacterial colony is decreasing at a rate of 0.03 n0 square. We have to change this to formula, so that means written in the mathematical equivalent. So the rate of change of the population, right, is negative 0.03 n0 square, because decreasing, therefore is negative, and n0 square. When t equals to 0. Therefore, we are asked to show that k equals to 1/100. So what do we do? So this thing implies that from here we can show that since when t equals to 0, what is my n? Now n is just n0, because n0 is the number of bacteria initially. Right, initially means when t equals to 0. Therefore, these two are equivalent. Alright, why do I need to convert this into equivalent? Because I do not know how to substitute. My dn dt is in this form. I don't know how to substitute t equals to 0 directly into it. So I find n when t equals to 0, which is n0, and then I substitute this n equals to n0 into it. right? Then I will be able to solve for my k. Purpose of this is to solve for my k, the proportionality, okay, to solve for this constant here. So then, since dn dt when n equals to n0 is minus 0.03 n0 square, I substitute back into this equation here. So it's minus 0.03 n0 square equals to minus k when n equals to n0. So n replaced with n0, so it becomes 4n0 square minus n0 square. Then 4 n square, n0 square minus n0 square is just 3n0 square. Then the negative sign in front, so we have negative 3k n0 square. Then this side, this is the equation. I just divided both sides by minus 3 n0 square. I divide both sides by minus 3 n0 square, and I have k on this side, and then 1 over 100 on this the other side. So that means k equals to 0.01 or 1 over 100. So we solve for the second part of this question. Now the third part of this question is that find the time that elapsed in terms of n0 at which the bacterial population reaches 0.75 n0 square. That means, in other words, they want to find the time at which the population reaches population is n. So I want to find t when n equals to 0.75 n0. And what is that? So in order to find this, right, we need to have an equation relating n with t, and we don't have it yet. We have to solve the differential equation. We have to solve, no, not this one. We have to solve the differential equation here. And since I already found my k, which is 1 over 100, so I just substitute this 1 over 100 back into this differential equation. Right, then we have dn dt equals to minus 1 over this k is 1 over 100, so minus 1 over 100 4n square minus n0 square. So I have this differential equation. Then from this differential equation, I integrate this differential equation to find an equation that relates n and t. Okay, so how do I integrate this equation here? I just keep 1 over 100 on the right hand side, and then just bring this n0 square minus 2n square over. And one thing is, n0 square minus 2n square is just equals to, using the factorization, and it will become n0 minus 2n and n0 plus 2n. n0 minus 2n multiplied to n0 plus 2n is just n0 square minus 2n bracket square. So then we have factorized this form, so we just divide over to the left hand side. And so when we integrate this, instead of integrating this, we integrate integrate this, right? So this actually is just divide both sides by this. Okay, therefore it's at the denominator. Then when I integrate the right hand side with respect to t, okay, I'll get t over 100 plus c, right? And then from here I'll use the partial fraction, the method of partial fraction here, because this is just one of the integration techniques. Because when I do a partial fraction, it will be easier to integrate these two terms than to integrate this term, right? So when I do a partial fraction, I let a and b be constants, and then after that I just multiply the denominator on both sides, and then we'll end up with this equation. Then from this equation, I use the cover up rule. I use the n to be n0 over 2, right? Then this term disappear, and then this will become 2n0, a equals to 1. So a equals to 1 over 2n0. The same can be said of for finding, the same method can be used to find b. I just let this n become minus n0 over 2. Then a, this term will disappear, and minus n0 over 2 for here becomes 2n0 b. So b equals to 1 over 2n0. So then I will just substitute this back inside. You just substitute this back into here, and then I have the equation. Since both of them are 1 over 2 n naught, I just factorize them out. So 1 over 2 n naught is factorized, and within it is just 1 over n naught minus 2n plus 1 over n naught plus 2n. So we integrate this, and what happens? So 1 over 2 n naught remains outside of the integral. Then when we integrate this, it's just minus half ln n naught minus 2n, because okay, to integrate this kind of expression, we just make sure that the numerator is the derivative of the denominator. So the derivative of the denominator is just minus 2, so I need the top to be minus 2. To make the top minus 2, I have to multiply a minus half outside of the integral, so that this explains why there's this minus half. And then ln, we just ln the denominator. That is the way to do this kind of integration. Then we do the same for this here, because I want a 2 on top, so because when I differentiate the denominator, I get a 2, so I want a 2 on the numerator, so I multiply a half so that I have a 2 on the numerator, and then I ln just the modulus of the denominator, and that will give me the integration on the left hand side. So then after that, I will just copy this on the next line, and then after we just try to solve for t when my n equals to 0.75 n naught. Okay, so then I will just substitute 0.75 n naught into the above equation. Okay, but before that, there's a constant, and then we know that when t equals to 0, n equals to n naught, where n naught is the initial population. Therefore, when t equals to n equals n naught, and then we substitute inside t equals to 0, so c is equals to just, I substitute n naught inside of here, I just get 3, because n naught plus 2 n naught is 3, then n naught minus 2 n naught is minus 1. So 3 divided by minus 1 is minus 3. Then modulus of minus 3 is just 3. Okay, the n naught will be divided, okay, because both the numerator and denominator has the n naught, so when divide, if it's not very clear, you just work out line by line by yourself. Don't look at my solution, just get the key idea and work out the algebra line by line, and you will realize how I get to 3. This thing, when I substitute n naught inside this equation, I just left with 3, and then here I'll just have 1 over 4 n naught ln 3. Therefore my c is just 1 over 4 n naught ln 3. Okay, this is just my c. Right, then t over 100 plus c. Then after that, for here, when I substitute n naught, right, then n naught plus 2 n naught plus n naught is 3 n naught. Then n naught minus 2 n naught is minus n naught. So 3 n naught divided by minus n naught will just give you minus 3, and modulus, no, sorry, here we don't substitute n equals to n naught here, because we are now, okay, we have already gotten the specific solution for particular solution for this after we found c equals to this. I substitute. Now I have this equation in terms of we have this equation and c equals to this. So what we need to do now is to find t when n equals to 0.75 n naught. So we are not substituting n equals to n naught. Sorry for the mistake earlier. So we are substituting n equals to 0.75 n naught. What is the question asking us is 0.75 n naught. So I just substitute 0.75 n naught into this equation. So 2 multiplied by 0.75 n naught is just 1.5 n naught. 1.5 n naught plus n naught is 2.5 n naught. 2.5 n naught divided by, okay, this is bottom would be n naught minus 1.5 n naught would be minus 0.5 n naught. Okay, 2.5 n naught divided by minus 0.5 n naught will just be 5. Okay, will just be minus 5, sorry, will just be minus 5, and because of this modulus, and it becomes 5. Alright, so 1 over 4 n naught ln 5 equals to t over 100 plus this constant. And so to solve for t, what I do is just your algebra, I just bring this over to the left hand side, and then I have since both of them have this 1 over 4 n naught, I just take ln 5 minus, I just factorize 1 over 4 n naught, and then bracket ln 5 minus ln 3. And using the ln rules, ln 5 minus ln 3 is just ln 5 divided by 3. Alright, and then multiply 100 over to the left hand side, and then we get this t equals to this. So after that, Then 100 divided by 4 is just 25. So 100 disappears, just 25 over here. 4 disappears, so 25 over here. So 25 over n naught ln 5 over 3. That is the final answer that we get for this tutorial. If you have any questions, feel free to email me at info at hour.com, which is info at. Feel free to email me at this address. Okay, thank you.